Hello everyone. This is Cadet Baran Matthew, and today we are going to talk about the Great Circle Sailing. So, first, we are given a problem. The problem is find the distance along the Great Circle, the initial course, final course, and the position of the vertex when sailing from 33 degrees 50 minutes south, 23 degrees and 12 minutes east to 20 degrees 10 minutes south and 104 degrees east. Also, find the latitude in which the Great Circle crosses 40 degrees east and 70 degrees east longitude. And lastly, verify initial and final courses by A, B, C tables. Okay, so first thing we need to do is to identify um, our initial courses. So we have here latitude A, which is 33 degrees and 50 minutes south, and has a longitude of 23 degrees and 12 minutes east. And we also have the latitude B, which is 20 degrees and 10 minutes south and 104 degrees east. So the next thing we need to do is to draw our great circle track. So first, we need to put our latitude A here, which is 33 degrees 50 minutes south and 20 degrees and 23 degrees and 12 minutes east. Next is our latitude B, which will be located at here, B, and that is 20 degrees and 10 minutes south and 104 degrees east. There. So after identifying the our great circle track, is next we need to find the D-long. So D-long will be using the South Pole. So D-long will be here and represented by P. So in order to get our D-long is we need to subtract our longitude. So since our D-long has our longitude A and longitude B has the same signs or same name, which is east, so we need to minus. So 104 degrees minus 23 degrees and 12 minutes. So we got D-long of 80 degrees and 48 minutes. So that would be the value of our P here, 80 degrees and 48. minutes. So after we get our d long, is we need to find the distance from latitude A to latitude B. So distance, and by finding the distance, so we need to use the cosine law. So it states here that cos AB is equals to cos d long times multiplied by cos latitude A times cos latitude B, and plus minus sine latitude A times sine latitude B. So we have our formula. Next is we need to put our latitude A, latitude B in this formula. So we have cos AB is equals to cos our d long, which is 80 degrees and 48 minutes, multiplied by cos lat A, which is 33 degrees and 50 minutes, times cos latitude B, which is 20 degrees and 10 minutes. And here, to identify with whether it is plus or minus, so we need to look at our latitude. If they have the same sign, so we need to add, and if they have different, so we need to subtract. So since it has the same names, which is south and south, so we need to add. So plus sine latitude A, which is 33 degrees and 50 minutes, times sine latitude B, which is 20 degrees and 10 minutes. So we need to input it in our calculator to get our distance. So cos AB, so we need to put it in a calculator. So cos that would be parenthesis cos our d long, which is 80 degrees and 48 minutes, times cos our latitude A, which is 33 degrees and 50 minutes, times cos our latitude B, which is 20 degrees and 10 minutes, then plus sine our latitude A, which is 33 degrees and 50 minutes, multiplied by sine our latitude B, which is 20 degrees and 10 minutes. So we will get the answer of 0.3166 0.3166158624. And next, to be able to get the degrees, so we need to inverse. So shift cos, and the answer. So we will get then 71.54. So we press this to get the degrees. So we will have now 71 degrees, 32 minutes to 32.5 minutes. So after this, in order to get our distance, so since distance is miles, so we need to multiply this by 60. So we will get the answer of 4,292.496629. So we will round it off into, so we will have distance of 4,292.5. So our distance is 4,292.5 and 4,292.5 miles. So that is our distance. So since we already have our distance, so next is we need to get our initial course. So we have the given our d long or p, which is equals to 80 degrees and 48 minutes. Latitude A, which is 33 degrees and 50 minutes south, and latitude B, which is 20 degrees and 10 minutes. So we are going to use this datas in order to get our initial course. So first is we need to solve the initial course of A. So A is, so we will use the formula tangent latitude A over tangent P, or the d long. So we need to write it tan latitude A, which is 33 degrees and 50 minutes south, over tan or d long or P, which is 80 degrees and 48 minutes. So we'll put it in our calculator. Tan 33 degrees and 50 minutes over tangent 80 degrees and 48 minutes. So we will get the 0.108562397. So we will have 0.108562397. Next is we need to get our B, initial course of our B, and has the formula of tangent and latitude B, which is latitude B over sine B or d long. So tan latitude B, which is 20 degrees and 10 minutes, and sine P, which is 80 degrees and 48 minutes. So we'll put it in our calculator. Tan latitude B, which is 20 degrees and 10 minutes, and sine P, which is 80 degrees and 48 minutes. So we will get 0.372053973. So since we already have our A and B, we need to get our C. And by getting C, so we only need to subtract our initial course of B and initial course of A. So it would be 0.372053975 minus 0.108562397. And so since in here in our calculator we already have the initial course of B, so we will directly minus it in the initial course of A. So 0.1 108562397. So we will get 0.263491576.3. So that would be the initial course of our C. Next is we need to use tangent easy equals to C by multiplied by cos latitude A to get the degrees for our initial course. So we need to use our gathered data, which is 1 over C, which is 0.263491573 times cos latitude A, which is 33 degrees and 50 minutes. And since we are using tangent, so we will inverse the tangent. So tan, and the answer of this is so 1, and the answer, which is the C, times cos 33 degrees and 50 minutes, which is our latitude A. So we will get 4.5688878472. So we need to inverse it. 4.568878472. So next is to inverse tan, and the answer, So we will get the degrees of south 77 degrees 39.25 minutes east. So why are we using south and east? So since our the location of our latitude A is below the equator, so we are using south, and it is going to the east to the latitude B, so we are using east. So since we are done in finding the initial course, so we need to find the final course. So we will use the same given, which is the d long or p, which is 80 degrees and 48 minutes, and we will use the latitude B as our latitude A. So latitude A will become 20 degrees and 10 minutes south, and our latitude B will become 33 and 50 minutes south. So we'll use the same procedure in getting the course A, B, and C. So the final course of A, which is tan and latitude A over tan P. So tan, and our latitude A here will be 20 degrees and 10 minutes, and then tan P, which is 80 degrees and 48 minutes. So I'll use our calculator. Tan 20 degrees and 10 minutes over tan 80 degrees and 48 minutes. So we will get the final course of A, which is 0.05948443109. So next is our final course B, which is the same as the initial course, tan and latitude B over sine P. So we have tan, and our latitude B in the final course is 33 degrees and 50 minutes over sine P, which is 80 degrees and 48 minutes. So we'll use our calculator. Tan latitude B, which is 33 degrees and 50 minutes over sine P, which is 80 degrees and 48 minutes. So we will get 0.679019237. So there. So next is C. So we will simply minus the B, final course of B and A. So that would be 0.679919237 minus 0.0594848 443109. So the value of our C will be, so we will need to compute first, 0.05948443109 to get our final core C. So our C will be 0.61953477726. So that would be our C. And to finally get the degrees of our final course, so we need to use tan AZ is equals to 1 over C multiplied by cos latitude A. So we have 1, and the value of our C is 0.61953477726 multiplied by cos, and the latitude A here is the 20 degrees and 10 minutes. So again, we will reverse the answer. So we have 1 over answer multiplied by cos 20 degrees and 10 minutes. So we will get 1.71953232492. And next, to finally get the degrees of our final course, is to solve it. Inverse tan and then the answer. And we will get the S. That would be north 59 degrees and 49.2 to east. So since we already have our initial course and final course, we need to get the true course, the true of the initial course and the true course of the final course. So here, since our initial course is having the name of southeast, so we will use in the notes that we will minus or subtract 180 for us to be able to get the final initial course. Initial. Final initial course, or shall we say the true course. So here we need to minus 180 degrees minus 77 degrees and 39.25 minutes. So the true initial course will be 102 degrees and 20.6 minutes. And in our final course, so since the direction of our final course is northeast, so we will use the same value for the um, final true course. So our final course is as is 59 degrees and 49.2 true 2 minutes true. Therefore our final or initial course is south 77 degrees 39.25 minutes, or 102 degrees and 20.6 minutes true. And our final course is north 59 degrees 49.2 minutes east, or the same 59 degrees and 49.2 minutes true. So since we are done in finding the initial course and the final course, so the last step is we need to find the position of the vertex. So in finding the vertex or the position of the vertex, we need to use the Napier's law. So PAV. So we need to find the position of the vertex by using Napier's law. So the the data that we need to use is, or in finding the vertex or the position of the vertex, is our initial course, which is 77 degrees. So we'll use A, and our initial course, which is 77 degrees 39.25 minutes, and PA. So in PA, it is stated that if your latitude A was has no intersection of the equator, so we need to minus, and it is shown here that in this illustration that our latitude A has no intersection to the equator, so we need to have 90 minus latitude A, which is 33 degrees and 50 minutes. So our RPA is, or will be, 33 degrees and 25 minutes. Is 56 and 35 minutes. So we will use the formula sine PV, position of vertex, is equals to cos 90 minus latitude A times cos 90 minus PA and sine times sine 90 minus PA and is equals to tan 90 latitude A minus latitude A and times tan 90 minus PA. So now we will use the data. So since we will find the latitude of the vertex, so we'll use cos the position of vertex is equals to sine A times cos latitude A. And so we'll have the derived formula of cos latitude of vertex sine, so we will use A, which is the initial course, 77 degrees 39.25 minutes times cos our latitude A, which is 33 degrees and 50 minutes. So we'll calculate it. Sine 77 degrees and 39.25 minutes times cos 33 our latitude A and 50 minutes. So we will have point 8114 15358, and since it has cos here, so we will inverse cos 1 to be able to get our latitude of our vertex. So shift cos answer, so we will get 35 degrees and 45.72 minutes south. And next is to find the d long from our A to the vertex. So we will use this formula, tan, and derive it into this tan P, or the d long from A to V, is equals to cotangent A times secant PA. So cotangent, our A is 77 degrees and 39.25 minutes times secant. Our PA, which is 56 degrees and 10 minutes. So we will get, so we'll have, since cotangent is 1 over tan 77 degrees and 39.25 minutes times cos 56 degrees, and since secant is also 1 over cos, so we'll directly cos 56 degrees and 10 minutes. So we will get 0.393106,404. So since it has tan, so we will inverse tan, and we will finally get, so shift tan 0.393106,404. So we will get 21 degrees and 27.19 minutes. So this would be our the position of our vertex. 35 degrees and 45.72 south, and 21 degrees and 27.19 minutes. So we already know our position of the vertex. So here the vertex will be here. The illustration, vertex we already have all the needed in this problem: the distance on and the great circle track, the initial and final course, and lastly the position of the vertex. So that would be all. Once again, this is Cadet Baran Matthew, and see you next time. Bye.